Hello, everyone. The topic I chose to research is free throw percentage amongst NBA basketball players based on their height. As you may or may not know, many big guys in the NBA struggle with free throws. Just to clarify, when I'm talking about big guys in the NBA, I mean power forwards and centers who are typically 6'8" and above. So the chart I decided to use, or that I got all my information from rather, is this chart right here on the right. I can't think of the exact website or what the website's called that I got it from. I'll include that in my post. But as you can see here, they have different rows based on the height. 5'9" and 5'11" are two separate rows. So to make it easier to read on the histogram that I made later, I just combined those two rows. As you can see here, all the way down, so I combined 5'9" with 5'11", I combined 6 foot with 6'1", 6'2" with 6'3", and so forth. So to do this, I had to, of course, add the 5'9" free throw attempts, which we see here is 394, with the 5'11" free throw attempts, which is 490, and combine that into one cell, which is really simple. I just let Excel do all of the math for me. No problem. I did the same thing with free throws made. Just punched in the numbers, let Excel do the math for me. And then to figure out the free throw percentages of Of course, I couldn't use the same free throw percentages we see on this chart on the right, since I combined the two rows. So once again, this is super simple. I just hit the equal button. I divided box E4, which is 692. I divided that by box D4, which is 884. Hit enter. It figures it out for you. So it originally didn't come out as 78%, as we see right here. It was originally some big decimal point or decimal, looked like that. So to simply make that in percentage, I just selected the entire column and clicked on the percent button right there, and that's exactly what it did. Really simple. These two charts down here are the charts I made for the different histograms I made. I made histograms, of course, because I'm dealing with quantitative data rather than qualitative. So this first histogram is a relative frequency histogram. As you can see, I've got the free throw percentages over here on the Y axis. The x-axis is the height of the various NBA players that they collected the data from. And looking at this data, you can see that all the bars are touching each other. Once again, of course, because it's a histogram. But when I originally made the chart, the bars were not all connected as we see here. So when I made the chart, I selected all this data, of course. Selected all this data. I went to Insert, chose Recommended Charts. I clicked on the cluster column, and they were all spaced out. As I mentioned already, histograms can't have spaces between each column. So in order to fix this, I selected all these, all the bars, and it originally looked something like that. Just slide the gap width all the way over to 0%. They're all touching. Change the color. I changed the color of each bar to make it more appealing or visually pleasing, easier to read. To do that, you just click on the paint bucket and you can switch to whatever color. I tried to have a color scheme just because I felt it could be a little easier to read, but you can change it to whatever color. I also had to add these titles right here. The original chart did not have those, so to do that, you go to Add Chart Element, Axis Titles, and Primary Horizontal and Primary Vertical. You just click on that, and simple as that, really easy. But anyway, getting into the data on this chart, as we can see, typically, the taller you get, the more you do tend to struggle with free throws. Here at 6'2", 6'3", they shoot 82%. 6'4" to 6'5", it starts dropping 79%, 77%, and for 6'6" through 6'7". And then we have a big drop, a 5% drop to 72% here for 6'8" through 6'9", and then we hit the lowest value, which is 69% at 6'10" and 6'11". Something that's kind of odd is once you get to 7 foot, it bumps back up to 73%. That doesn't follow the trend we're seeing here in this histogram. Once we go back to the original table, we can see that the amount of subjects that are 7 foot and above that we collected this data from, there is far less than 6'10", 6'8", 6'6", so forth. There's far less, so even if there's like 10 players that are 7 foot and above that are abnormally good at free throws, that could really throw off the trend. So what I would like is for there to be more 7-footers and above that I guess were in this, to be included in this data. So that way we could get a definitive feel for whether or not maybe 7-footers are just break the trend, or maybe it's just because we didn't have enough 7-footers and there was enough outliers that it was able to change the data from what the norm is, if you will. But anyway, this data makes sense to me, that the shorter guys would be better at free throws. You wouldn't be able to make it in the NBA as a 6'2" or 6'3" player if you weren't a good shooter, because you couldn't hang with down in the paint with the 7-footers. You get blocked all day. So that typically makes sense. As we see, this histogram does prove the hypothesis that taller guys, big guys in the NBA tend to struggle with free throws more, except for that little outlier we have there, 7 foot and above. Kind of throws a wrench in things. For this second histogram I made, blow it up a little bit. I created it the exact same way. Got all the bars to touch the exact same way as I showed in the last on the last page. Except for this time I added the actual values on each bar, just to make it even easier to read than the last histogram reviewed. To do this, I went up to chart design, and you can click on various chart designs, whatever you want. As you can see, this is the one I chose. Of course, I edited a little bit to get it to look like this, but that's how you choose to get the values in each column. But looking at this chart, there doesn't seem to be any correlation with height and free throw attempts. Originally, I hypothesized that bigger guys would have more free throw attempts since they are, on average, worse shooters at the free throw line. I figured they'd be fouled more in late game situations when the other team needs the ball and the clock to stop. However, this doesn't seem to be the case. As we can see here, shorter guys have more free throw attempts than a lot of the bigger guys. So that kind of threw a hole through that hypothesis. To clarify as well, we'll go back to this chart. You can see the number of players I have here is not the same throughout. Like there's 5 players that are 5'9", 5'11", 37 players that are 7 foot and above, and then we have 109 that are 6'8" through 6'9". So what I did is I figured out the average each player shoots based on their height. So this is an average over an entire year of how much they shoot. This was really simple to figure out. Once again, I let Excel do the math. You hit the equals, and I divided D4, which is free throw attempts, divided by the number of players. I did that all the way down, and that's how I figured out free throw attempts per player per season, just to kind of even things out since there's different values under number of players. A big plus to using these histograms, as we see here, is it's a lot easier to read or compare data rather. It's a lot easier to find any trends. As we see here, we can see as you get taller, your free throw percentages tend to go down more. So it's a lot easier to read trends and just overall easier to read. Everyone that I know can read a bar chart, so nothing really too complex about it.